the learning intentions and success criteria for this lesson was about allowing that bridge from the calculus and highlighting the calculus rules and knowledge that they had, and then bringing in the trigonometry, and so that the two different aspects were connected. So it was really a learning intention and success criteria that had to bring both of those things together and illustrate why they're both important. The way that I teach this class is by using a lot of puzzles to engage their minds and offering them opportunities where there's multiple solutions, and then they need to discuss and understand which of those solutions are correct or incorrect. We are going to start with a puzzle. It's really about exploring not only the actual answer, but how to communicate that answer and how to evaluate it against other options. So first thing I want to know is, what observations did you make? Before you started trying to solve it, what things did you notice about the question? The reason that I taught my lesson using multiple options for the students was that I wanted the students to have lots of chances to sort of come in. So they started off with a puzzle that was really more of a stuff they would have done in year 11, but then that puzzle did link to stuff they need to know for this. So that was confirming the prerequisite knowledge. Then I gave some examples, I showed some things on the board, and I also got them to fill in a unit circle. So it was about being able to say that it was their knowledge, they already knew what they needed to do. Although some of them benefited from the support of others around them, they then had that knowledge to then develop further and take that idea and take it with the new calculus knowledge that they've just been developing. So tangent's really helpful for slope, and it's helpful for finding when x equals 1, what's the y component going to be. So that was just refreshing, making sure we're okay with our trig functions. It's now time to put our thinking caps on and talk about slopes. And then at the end, it got down to them using their actual pen and paper and writing what they understood through those exercises and checking their understanding there.
When I was doing some of the questions, I thought it was just easier. Like I wrote both ways, like using sec and cos. But I feel like it's just easier because then you don't have fractions.
Absolutely. So you know how you're talking about the h over, like the hypotenuse over the adjacent rather than adjacent over hypotenuse. Sometimes it just makes more sense to be that. So it's definitely, there's a reason they use them, but it's not included for us. So as long as you can sort of switch between them, that's fine. Use them as a tool for you and then
I thought it might just be easier to get rid of all those fractions.
Yeah, absolutely. I think one of the things that the students really enjoy is that I use technology to allow them to keep records of what we're doing. So everything I'm doing on the screen, they're able to access offline or at other times, so that they're not needing to spend the whole time repeating whatever's on the board. It's actually, they can access that whenever they want. So I've done a fair bit of PD that actually helped me understand how to set that up so the classroom works in that way. The benefits of ICT being interactive, that they can also access their own selves if they want to do some more exploring. And that was something I was able to also bring into the classroom as a way to really get the students kind of hands-on with concepts, which can sometimes be tricky in mathematics, but the concepts themselves really do lend themselves well to computerized technologies. At the end of the lesson, I think it's really important for the kids to summarize, capture what they've thought. So, what things have we learnt so far? Happy to take. Yep.
Yes, the derivatives of trigonometric functions like sine, cos, and tan.
Yep.
I thought it was cool how we used different calculus skills that we learned how you don't know how to apply them to trig, and that's how the same thing. But
So what was it? So how you
can apply the calculus stuff to trig.
How to apply calculus to trig. Love it. The summary really is about them taking ownership of their learning and saying, there was some information I already knew, there was some information given to me, I now have a new set of information that I now know, and that summary then meant that they can collect all that up and have it as a part of their understanding, not necessarily something external, but something that they should internally understand about how calculus and trigonometry fit together.